Okay, we are finishing Doodle Sheet 1, Lecture 2, or Day 2 lecture. Okay, so today we're going to be talking about what really is required for an organism to survive, right? What do we need to survive? Okay, so I'm not going to make you guys pull out whiteboards, but what you are going to do is you are going to talk about it with someone sitting next to you. Okay, so I want you guys to come up with a scientific answer for what is poop and what is pee. Super fun topics, right? I'm sure you guys just love to talk about this right before lunch. Okay, so and this, what are the other things? Like, what are the other outputs that are on that list? What scientifically, why do we make those things? Okay, so I'm going to give you guys about a minute, have an answer, because I'm going to call on 2 random people to give me what they think the scientific purpose of poop and pee are. Ready, set, go. Oh.
I think because of the excess of afterlife, their bodies.
That cup was broken. That cup was. Man, you guys, I'm a mess. I spilled my coffee this morning all over my keyboard. And then my cup that I made my cider in had a hole in it. Everyone's out to get me today, guys. What's going on? Okay. It was like cracked down the side. Well, okay, fine. It was cracked. Okay. Izzy, what's poop? Scientifically, what do you think poop is? You don't know? Okay. Cooper, what do you think poop is? From what? So excess waste from the digestive system, maybe. Okay. Justin, what do you think pee is?
I believe pee is the waste from liquids that you consume in your body.
So waste from liquids that we consume in our body. Okay, good ideas. Good ideas. Okay, so what is poop? Okay, so this we have a human digestive system. So no, this is not to scale. It's actually, the scaling on this is all messed up. Okay. So what happens is we chew our food. Okay, that is called mechanical digestion. So we physically break it down, okay, by chewing it. We swallow, it goes down the esophagus into our stomach. There we have all these chemicals, and your stomach physically churns it, okay? And that helps chemically break it down. So it's starting to break down into different molecules, okay? Or into smaller molecules, I guess. Okay, then it goes into the intestines. So your intestines are kind of cool. Your intestines are actually 22 feet long. So if we were to pull it out of you, we could like stretch it like, maybe not across the room, but from like that door to like the end of the table. So your intestines are really long. Okay. So what happens in the intestines is the stuff you ate and drank slowly go through it, and the intestines pull out the nutrients and liquid that we need for our body. Okay. Okay, so nutrients are absorbed in the bloodstream and taken to the cells, right? Where the cells does what it needs with it. What? No, you don't have to write this down. Okay. The materials that can't be used are excreted as waste. So that's your poop. So the things we can't use, we get rid of as fecal matter, which is poop or feces. I'm telling you guys, I just need like a sticker or a magnet of the poop emoji so I can like, ha. Okay. So what's in poop? So it's actually mostly water. Okay. The other 25% is undigested food, bacteria, and cell waste. You better be glad it's mostly water, because if it wasn't, it'd be like pooping out rocks. And you don't want to do that. That sounds terrible. Okay. And what is pee? So pee or urine is mostly cell waste filtered from the blood by the kidneys. So it's extra stuff in the blood that your body doesn't really need. 2% is a chemical called urea, which is what makes your pee yellow. Fun fact, we actually also sweat out urea. So that's kind of why your sweat is salty a little bit. And the other substances such as salt. Okay, and it's 95% water. Okay, now you're writing this down. Okay, inputs and outputs. So looking at our inputs and our outputs. Box H, how are they the same? How are they different? Well, they're the same because they have the same molecules. Okay, our inputs are made of carbons, hydrogens, oxygen, and nitrogens. And our wastes are also made out of carbon, hydrogen, nitrogen, and oxygen. Okay, they're different because they've been rearranged. So my venti half-calf caramel brulee latte that I drank is not going to be the same thing. Is not going to be the same waste that comes out of me. It's going to be something different. It's like whatever you ate for breakfast is going to be different than what comes out of you. Okay, except for corn. We don't digest corn very well. It's too fibrous, I think. Yes. They're different because they've been rearranged. The what?
They have the same molecules.
Yeah, so they've been structurally rearranged. Okay, so what's happening to matter? Box I. We take in matter, rearrange it. The body uses some and discards the other, right? We need those vitamins, those minerals, those proteins. Okay, and whatever we don't need, we just get rid of. Okay, so adding to our model. So scroll up to box B. We're adding inputs have been rearranged. Okay, the outputs are just the rearranged molecules from the inputs. Okay, so you're going to scroll up to box B and add this. Oh, I need to use the mouse. The computer people. The inputs have been rearranged into different things. Okay, so these are made of the same atoms that we ate or drank. They're just rearranged into new forms. Okay, so, So why do we transform stuff? So the average American adult takes in 5.5 pounds of food per day. Right, that's a lot of food. So we eat more than we think we do, right? Now let's look at the uses and outputs on our IOU diagram for a moment. In adults, only the tiniest bit of matter that we consume is retained by the body. Most of it just passes through. So almost all of the matter that comes onto our body is simply rearranged. So we're going to look into why. Okay, so box J. Matter transformation gives us molecules our body needs and energy to help our cells perform life processes. I'm sorry. We good? Okay. Okay, so what about energy? So this is the chemical reaction that we used when we were talking about the combustion of ethanol, right? So ethanol plus oxygen reacts, we get fire, and it's rearranged into carbon dioxide and water. So all we've done is rearrange the atoms, but how does this give us energy? Okay, since it's all about energy, what do we know about the energy in our inputs? Remember, we take in food as calories. I know we haven't talked about calories yet, but calories are the measure of how much energy is in a food. So something that has 10 calories is not as fueling as something that has 100 calories. Okay? Let's see if we can figure out how we get energy from our food. Okay, what's in a Cheeto? So this is the ingredients for hot Cheetos, Flamin' Hot Cheetos. Okay, we all love hot Cheetos. They're so good. They're so yummy and spicy. I like the lime ones. They're my favorite. Lime hot Cheetos. They're the what? You know what's weird? I completely agree. Is that I worked on the East Coast for a couple summers and I couldn't find them. They lime hot Cheetos. They didn't exist on the East Coast. It was so upsetting. No, normal hot Cheetos were there, but I could not find lime hot Cheetos. I literally had to call my parents and beg them to ship me lime hot Cheetos. They did because they love me. Okay, so these are the chemical structures of some of the ingredients. Okay, these lines indicate bonds. Okay, those are the bonds, the things that connect the atoms. Okay, the force that pulls them together. Okay, so how we get energy is that, oh, hold on, I skipped ahead, go back. Is that in each of these bonds, it's called potential energy. So when we break those bonds, it releases the energy. So not every single bond, right? But some of these bonds, when broken, will release energy. Okay, this is called potential energy. This is the energy that is stored or invisible energy that could be released. So when we break the bond, energy is going to be released between some of those atoms in those molecules. Okay, so this is a click and edit. So you're going to have to click on the image, go to edit so you can move stuff. Okay, but here in this chemical reaction, we have reactants. So reactants are the things before the chemical reaction has happened. So that's the food, that would be the food that we're eating, or the ethanol before we burned it. Okay, so those have high potential energy. Okay, after they've been rearranged or burned, in the case of the ethanol, those new products have low potential energy because the energy has been used. Okay, so box K, energy is stored in chemical bonds. Energy is released as bonds are broken and atoms are rearranged. So once the bonds are broken and the atoms are rearranged, it goes from high potential energy to low potential energy. You see a couple people still clicking away.
What do we put in the picture? Like the yellow space, or do we put that?
Hold on. So on this image? Hold on, I don't have it in front of me. Give me a second. Nope, that's not the Doodle sheet. Oh, it's the word released. You're typing in the word released. Yeah, energy released during reaction as bonds break. Okay, so this is the last thing, box L. Okay, you're going to click on the image, go to edit, and you are going to move the words to match what it says here. So high potential energy is going to be under inputs. Also, energy stored in the bonds of these molecules under inputs. Okay, in the middle, you're going to put matters rearranged, bonds broken, energy released. Okay, outputs, low potential energy and matters rearranged. You are also going to retype in the uses because that's empty. Okay, so once you've done this, that's it. That is the end of lecture or Doodle Sheet 1, Lecture 2. Okay, so next we're going to move on to Doodle Sheet 2, Lecture 1. Okay, so go ahead and open that up so we can get started on that. Those of you at home, I hope you guys had a good time with this lecture, and I'll see you in class